I'd now like to introduce our first speaker, Dr. Jeff Wammes. He's an assistant professor of psychology at Queen's University and the director of the LAMP Lab, the Learning, Attention, Memory, and Perception Lab. Jeff earned his PhD from the University of Waterloo, and he completed a postdoctoral fellowship at Yale University. His work uses behavioral, computational, and neuroimaging methods to understand how we reorganize, strengthen, and retrieve information and memory. He also studies how mind wandering and other forms of inattention influence learning. And I've had the great pleasure of having many conversations with him, especially over the last little while, as both of our labs have really been pivoting to understanding how we can improve online learning conditions. Wherever possible, his research extends findings and theory from the lab into relevant real-world settings, including entire semesters of lecture-based undergraduate courses. Please join me in welcoming our opening speaker, Dr. Jeff Wammes.
All right, thanks, Joe, and thank you all for joining me, I guess, in my kitchen on this beautiful Friday morning. So this is a bit of an interesting experience, giving a talk to a blank screen. Us as educators are more accustomed to giving talks and, you know, hopefully seeing something that looks a little bit like this. So a lot of educators, instructors, people interested in education's relation to cognition in the audience. And so I don't think anyone would argue that this is kind of our ideal scenario for an audience. We have a bunch of speakers hanging on our every word, taking notes, paying close attention to what's happening. But in actual fact, it's probably more frequent that we see kind of something more like this, right? Or the equivalent, I guess, in the era of Zoom meetings is a bunch of people with their cameras off and very little interaction in the chat. So that sort of behavior, that inattentive look on people's faces, might be described as mind wandering. And that's primarily what I'm going to be talking about today, is mind wandering and how it applies in educational settings. In particular, my work is focused on live lectures in actual classrooms. But obviously, with the pivot to online learning, we are shifting our methods to be able to focus primarily on the online audience. So mind wandering has been described under several names in the literature. This includes zoning out, task unrelated thought, freely moving thought, etc. And I think most of you will have a colloquial understanding of what mind wandering means to you. But the way we operationalize it in our research is consistent with Smallwood and Schooler's 2006 definition as a shift of attention away from a primary task and toward internal information. So how is this measured? We're going to take a step back and look at how mind wandering is measured in more traditional laboratory tasks. So I'm just going to show you a few examples of tasks that are commonly used to study this sort of inattentive behavior. So this is one, and it was meant to simulate people who act as radar detectors, for example. And the basic premise of this task is that this red dot is going to move one step at a time clockwise around the circle, and your job as a participant in this sort of experiment is to identify when that dot skips 2 spaces instead of 1. So I'm just going to start that, and you can take a look. It's going 1 space at a time. Now it skipped 2. So if you missed that one, don't feel too bad. Most people miss these targets because it's a pretty mundane task. And as we kind of watch as the red dot moves around, eventually it'll skip twice again, and your job is to just kind of press a button when that happens. So there it was. So yeah, this task is quite boring. You have to maintain your attention, and people kind of operationalize lapses in sustained attention as occasions where you miss that point where the dot has skipped twice. You've only had to view this task for about 20 to 30 seconds, but in the lab, we might have people do this for as much as 25 minutes. So I'm letting you off the hook on that. Another example is this Starry Night task. And in this task, your job is to watch this field of stars and press a button when one of them disappears. And so I'm going to give you a very subtle hint about where that might be. And so we can just watch this display. All right. Now that one I hope you probably caught. And then the last quick example is we show people a series of digits and we have them press a button every time they see a digit, except for when that digit is a 3. And here we can catch errors in this boring task when people accidentally press for a 3 or fail to press for any other digit. So let that go for a moment. So we're pressing a button, numbers come along, there's the 3. So you weren't supposed to press on that occasion. And so this task we've had people do for as long as about an hour. And as you can imagine, people are painfully bored. And in some cases, we actually have participants fall asleep. But the take home from this is that in these basic laboratory tasks, people tend to mind wander about 40% of the time. Maybe not surprising given how boring these tasks are, but mind wandering behavior is also observed in a variety of everyday activities. So that includes working, studying, even having conversations with people. The mind wandering rates are quite high. So just to point out a few of these, I showed you the radar detectors. Mind wandering has been observed in these settings. Also on the top right there, we have someone studying. On the bottom left, someone bored to tears in our lecture. On the bottom right, driving. So mind wandering actually tends to occur while you're driving as well. So you may have had the experience of being on the highway and you kind of zone out and then realize you've driven more kilometers than you expected. And so in this circumstance, it's particularly dangerous. So I'm going to show you a short video. And just before I play it, just know that everyone in the video is okay. So.
This is the view from cameras mounted inside the DART paratransit van. You can see the driver wasn't talking on the phone or texting. He was looking straight ahead when he slammed into the back of Jose Sepulveda's black Nissan Altima. The bus driver appears to be paying attention. He plows into the line of cars waiting to exit onto I-35. But in this view from TxDOT cameras released last week, you can see he never even tapped the brakes before the crash.
Okay, so in the laboratory tasks, the real world consequences are you might get a little bit frustrated that you missed a 3. Here, the consequences could be risk of severe injury and dramatic destruction of property. So the circumstance that I'm going to be talking about is somewhere in the middle of those two things. In particular, I'm interested in educational settings. So the consequences of not paying attention aren't as immediate or damaging, but in the long term, you attend these classes because you want to learn something, because you want to get a degree, because you eventually want to get a job that you desire. And so not paying attention or failing to actually engage with the lecture content can have long-term consequences on your learning. And that's sort of the thing that I'm going to be trying to outline for you today. So how do we measure mind wandering? Often people collect retrospective reports, which is to say that you do an entire task. And then after you've completed the task, we ask you to what extent were you paying attention to what you were doing relative to mind wandering. And so that gives you some information, but it's relatively non-specific in time. You can collect trait level questionnaire measures, which just ask people to indicate in their everyday life how much they mind wander and to describe that mind wandering behavior. Thought sampling is a common approach as well. Essentially what this entails is you can imagine you're doing that task where you're tracking the red circle around and round. Every once in a while I stop the task and just say, just prior to this screen appearing, were you on task or were you mind wandering? And you can ask various versions of that question, but the point is it's pretty specific in time, and we incorporate those probes, and then based on your responses to those probes, we can kind of generalize to how often you might mind wander in general. And then the last example is experience sampling, which is where you might have an app on your smartphone or keep a diary, for instance, where you're asked to make note of every occasion when you catch yourself mind wandering in your everyday life. There's also many indirect measures that kind of map on to mind wandering. That includes variability in your response times when you're pressing for those numbers, for example, error rates, fidgeting, for example, eye movements, etc. When you're driving, your driving speed is more variable and you're more likely to follow more closely. When you're reading, you don't do it as quickly, you don't understand as well. And in one interesting example, you're not able to solve Sherlock Holmes mysteries as easily. And then in the educational setting in particular, we can look at quiz or exam performance. And then a particular question for studying mind wandering during education is, how do we do this? So we could study video recorded lectures, which is often done, and that's where a lot of the educational work has been. Simulated lectures, where you bring people into the lab or into a lecture hall and show them a lecture or deliver one. But in that case, they're not enrolled in the class, so it's not like a real course where they have skin in the game. Or live lectures. And so this is the traditional setting where people come into the class and it's for a course that they're enrolled in. And then obviously we can do that either in the laboratory, online, or in the classroom, and there's every possible combination of those things. So most of the work that I do involves mostly thought sampling during lectures. We also map onto trait level questionnaires. Our main performance measure is quiz or exam performance. And most prominently, we've done live lectures in the classroom, although now we're moving to doing live lectures, but online through the remote learning model, and occasionally have done some video lectures. So today I'm going to talk about three kind of main topics. The first is kind of the temporal trends in how mind wandering behaves over time and over the semester in lectures. The second is factors that influence mind wandering. So what are some of the reasons that people might mind wander more or less? And then the last thing I'll get to is using what we learned in those first two sections to develop some potential future interventions where we might be able to either prevent people from mind wandering or redirect their thought to something more productive, like elaboration or making connections between what you're currently learning and what you've learned before in the course. So we'll start here. Okay, so in terms of temporal trends in mind wandering, the overwhelming majority of studies find that attention decreases over time. And this goes back to kind of radar detector studies in the 40s, but also applies to other tasks where mind wandering increases over time, and also in educational settings in video and simulated lectures where rates of mind wandering increase from the first to the second half of lectures. And so what we wanted to do was test whether these trends hold up when we're in real live lectures where students have purposefully enrolled in this course and have some investment in learning what's being delivered to them. So first of all, are the rates similar? And second of all, do they change over time in similar ways? And so to do this, we needed a willing instructor, and we found one in the teacher of physiological psychology at the University of Waterloo. And so just to give you a basic sense, this course is about brain and behavior. So they cover brain anatomy, right down to the level of the neuron and up to more coarse structures like the lobes of the brain. And then they link those things to behavior. And so they cover all the greatest hits like the visual pathways, the cranial nerves, the action potential, and all that good stuff. And so we took this class and we had to reason about how we could study mind wandering in these students relatively unintrusively over an entire semester to get a real sense of what the real world trends in mind wandering are. And so the structure of this class is basically a lecture with slides accompanied by a narrative. The instructor got through about 20 to 22 slides per lecture. At the end of each lecture, students use the iClicker to answer up to 6 quiz questions as part of their participation grade. And then sometime down the line, after a bunch of lectures, they get an exam that tests their knowledge of all of the content. And so what we thought is that maybe at certain points in the lecture, we can insert into the slide deck directly these thought probes. So this is the thought sampling method, and we basically ask which of the following responses best characterizes your mental state just before this screen appeared. And then they can report that they were on task, intentionally mind-wandering, or unintentionally mind-wandering. And this is using the clicker that they were already required to use for their participation grade. And so before each lecture, there were two of us working on this study, or I guess spearheading it. We would start with the assumption that the instructor would get through about 20 to 22 slides per lecture. So at the start of the semester, we laid it out so that the slide numbers at which we inserted these probes were pseudo-randomly distributed to get a good coverage of the entire duration of lectures. And of course, through the iClicker, we can know the exact time point at which each probe was responded to. So we insert these probes directly into the slide deck. And at first we did 2 per lecture. We've done as much as 3 per an hour lecture. So the probe appears randomly during the lecture, and then the students give their response. All told, this takes about 15, 20 seconds, and then they move on with the lecture. And then on the next class, those 2 probes will appear in a different location. And the idea is across the entire semester, we get a nice distribution over the entire duration of the lecture. And so aggregating across that, we can get a sense of what the actual rates of mind wandering are in the lecture setting. And so remember, in most of those laboratory tasks, it's approximately 40%. So I guess like optimistically, we were hoping it would be less, given this is a lecture that students actually choose to attend, right? So their overall mind wandering rates were actually just over about 30%. So lower than the laboratory tasks, but not as much as we'd hoped. So students are actually mind wandering about 30 to 35% of the time during these lectures. And I won't get into the details about intentional versus unintentional. Aside from that, intentional means they're actually making an explicit choice in their view to think about things completely unrelated to what you're teaching at the time. And this intentional form of mind wandering actually tends to occur more often than unintentional, which is pretty striking. But also optimistically, if they're doing it intentionally, it means they have some control over the situation. So it's possible that with targeted interventions, we might be able to help them reduce this behavior. Going back to the actual time span, what we have is on the x-axis here, the quarter of the lecture. So we're splitting this into 4 bins and looking at how mind wandering changes over time. And what we see is that contrary to all of that prior research that showed an increase in attention over time, we're actually seeing mostly a stable pattern over time, if not a slight decrease towards the end of the lecture, possibly in anticipation of the quiz questions. But in any event, we're certainly not seeing an increase in mind wandering over time. And that pattern holds true in both intentional and unintentional mind wandering as well. Okay, so just to make sure that we're actually mapping this to some reasonable performance metric, what we would do before each lecture is essentially one of us, of the 2 who are kind of designing the quiz questions, would take the slide numbers at which the probes were presented, and then take the slides just before and just after each probe, as well as another pair of slides that wasn't paired with a probe at all, just as a control. And the one person would take those 6 slides, shuffle them up, and send them to the other person, who would laboriously write a quiz question, the night before the lecture about each slide, shuffle the order, and then send them to the instructor to put back into the slide, the end of the slide deck. And so what this means is that for every thought probe that we present, or for most thought probes we present, we have a sense of what content was presented just before and just after, as well as how well people learned that content on the aggregate. So this is how it would look. They would essentially be seeing some content, And then at a certain point, a probe would appear. We would target the slide just before and just after and write a quiz question based on that material. And then we can subdivide the quiz questions based on, for a given participant, whether it was reported that they were on task, intentionally mind wandering, or unintentionally mind wandering. So that's what I'm showing here. So on task performance is about 63% accurate, with chance being 0.2 because it was with 5 alternatives. And in both unintentional and intentional mind wandering, performance is slightly lower, though only reliably so for the intentional mind wandering. So it seems that this sort of mind wandering is particularly damaging to performance. And then if we look at this at the level of individual differences, so are people who mind wander more also more likely to do poorer on quizzes? And maybe more importantly, are they more likely to do poorer on final exams and evaluations that actually contribute to their GPA? So we'll take that exam performance. And what we find is that intentional mind wandering predicts how well people will do on the quizzes. This is not surprising given the group level effect that I just showed you. And then it's only unintentional mind wandering that predicts their final grades. However, their quiz scores are also a strong predictor of how well they do on the final exams. And so there's an indirect effect of intentional mind wandering on grades. And so it seems like both forms of mind wandering are having these strong detrimental impacts on final exams. And this is especially interesting because the immediate performance effects on quizzes is perhaps not all that surprising. If they're not paying attention to the content in that moment, it's pretty unlikely that they're going to get a quiz question correct. But in the final exams, they've had all this intervening time to actually review content and study, and there's still an effect of in the moment unintentional mind wandering. That effect is long-term on their exam grades. Okay, so it was pretty striking to us that we didn't find an increase in mind wandering over time. It seemed that attention was quite stable. So we started to try and poke and prod this finding to determine whether there might be something we're missing with our measurement. So the first thing that we did is try and study whether there were different degrees of mind wandering. And the reason for this is because it's possible that by enforcing a kind of dichotomous choice, more or less, that people are having to choose whether they're on task or mind wandering. And if you look at this picture, for example, this particular person could probably endorse one or the other. It looks like she's paying attention directly to the instructor, but you can also see that she's bored, so she might be internally trailing off, right? So she could probably go either way, depending on where her threshold is. Whereas her friend here is almost undoubtedly mind wandering. She's not even looking at the instructor, barely paying attention. So the question here is, maybe these are different degrees of mind wandering, but if we force them into a dichotomous choice, they might indicate one or the other. So I'm just going to put those on the x-axis. We did basically the exact same study, but with a degree of mind wandering, where they have an option to rate whether they were completely mind wandering, which is at the bottom of the y-axis, or completely mind wandering is at the top of the y-axis, and completely on task is at the bottom. So higher equals less attention to the lecture. And what we see here is basically that same kind of non-significant linear trend. So they're not changing how much they're tuning out over the course of the lecture. They're just kind of uniformly zoning out. So time doesn't appear to be a strong factor here, at least in this kind of internal mind wandering. And just like in the other study, we mapped this onto performance. And what we see is that they get around that kind of 60+% mark when they're reporting that they're completely on task. But as you shift more towards mind wandering, you get this kind of stepwise decrease in performance that's mapping onto the extent to which they're mind wandering. So this shows us not only that people are able to use the scale effectively when they're reporting like the degree to which they're mind wandering, but also that our performance metric is affected by how much they're on task versus disengaging. Okay. And then, so the last thing that I want to touch on as a potential confound to rule out is that when we're inserting these probes, it's relatively intrusive, right? So the lecture's going along, maybe you have a pretty strong focus, maybe you're in a state of flow, for example, and then this probe comes up and it kind of disrupts the ongoing narrative. So we opted to try a less intrusive measure. So with the help of some collaborators, we designed an app that runs on each student's computer. And it periodically pops up a screen that looks like this. Students are asked to indicate using a slider whether they're completely mind-wandering or completely on task. And this just shows up in a small corner, the bottom right of their screen. So the app kind of lays dormant on their computer for most of the time, and after they input their class schedule at the start of the semester, it knows when to appear and to start probing them with these questions. And the nice thing about this is because it's independently random for each participant, there's no like universal disruption of class. It just kind of goes straight through, and each person gets probes at a different time. And they also have this option at the bottom to not respond right now or to ignore the probe, which is totally fine. People don't do it often, but it's just to give them a chance to kind of shoo us away if they're paying close attention and don't want to bother. And so in this model, you can probe one person at this slide location, or it's determined by time point, but at this point in the lecture. Another person might get their probes here, another person here. And then on the aggregate across people and across the semester, you get this really nice distribution of probes over the time course. And so just to make this concrete, what I'm showing here is the time elapsed in a given lecture along the x-axis. And these purple circles, the size of them represents how many people we get responses from, and the location is where they occurred. So you can see that we're probing at these kind of discrete locations, and we're getting a variable amount of responses from our population. But there's these big gaps where we're not really collecting any information. So by independently randomizing, we're able to get something that looks more like this. So each blue dot is a single probe response from a single participant. The extent in the Y direction is not important. It's just to show that, you know, there are no gaps any longer. And we're getting this really nice coverage of the entire time course of the lecture. And so this is much less intrusive. We get better coverage. Maybe now we'll see an increase in mind wandering that's been so characteristic in the literature. And so these are a bunch of the responses plotted. It's a bit hard to make out, so I'll just do a moving average to clean that up. But the point is that this is a flat line. The correlation is about as close to zero as you can get. So students are just kind of, you know, universally across time, just not paying that much attention. So this is a problem. And hopefully in the next few sections, we'll address how we might be able to help them solve that. So in this section, we show that mind wandering is stable and reasonably high over time. More often than not, it's intentional. So students are choosing to not pay attention to the content that's being presented to them. And mind wandering hurts performance. It's obvious in some cases, like in the immediate quizzes, but also this long-term effect on their exam performance. And so next, we wanted to determine what are some factors that potentially determine whether people will mind wander or not. So we'll move on to that section. So one thing that might be of interest is the format of presentation. So I mentioned in one of the prior studies in the lead up to this, that they used a video or a simulated lecture. So it's possible that that video lecture format is more conducive to high mind wandering rates or increases in mind wandering over time. And I think this is especially relevant given that online lecturing is moving in this direction. And so there might be different challenges in that space in terms of sustaining student attention. So what we did was we took a lecture that we probed during in one study, we video recorded it, and then the next time that course was run, we showed this video to students enrolled in the course before they had reached that lecture in the syllabus. So we have the exact same lecture, the exact same probe locations. The only difference is that in one case, it's a live lecture. In the other case, it's video recorded. And within the video recording, we had one group that was actually enrolled in the course that I just mentioned, but we also had a group that wasn't enrolled in the course. So they have no investment in the content. And that's kind of to model the simulated lectures that people have used in this sort of research before. So what I'm plotting here, the gray bars in the background are the group level function of mind wandering, degree of mind wandering over time in the lecture across the entire semester. The orange line here is the degree of mind wandering when the lecture was run live. So you can see that it's more or less flat. If not, there's a decrease towards the latter probes. So what happens when we show the video version? So the blue line is the people that were actually enrolled in the course. The first thing to notice is that you see an increase in mind wandering over time, but no main effect. So they're mind wandering about the same amount overall, but there is this kind of increase over time that occurs in the video version. And the people who aren't enrolled in the class have that same increase, but maybe their degree of mind wandering is even worse. So they're paying even less attention, which isn't surprising given that they have no investment in the content. So what this tells us is that there might be something about the video format that's leading people not to mind wander more on the whole, but potentially to not be able to sustain their attention for as long. Of course, there are clear differences in this relative to online learning, where you can actually choose when you watch it. So it might be an ideal time for your attention. And you can pause and play when you zone out. So this obviously has a lot of things that make it not particularly analogous to online learning, but we still think that video delivery is a relevant factor in determining mind wandering. Okay, and then so the other thing is that the people who aren't enrolled are mind wandering a little bit more, and this hints at a role for some form of intrinsic motivation to learn the content that's being presented to them. And so we've looked at this as a factor before, and it turns out that motivation is a strong predictor of intentional mind wandering, of the degree to which people mind wander, of how much people use their phone or laptop when they're supposed to be paying attention to the lecture. And while it doesn't predict dichotomous mind wandering, the balance of evidence kind of points towards motivation being a strong factor. And this, coupled with the idea that people are often intentionally mind wandering, again, gives us like kind of an optimistic perspective, because we know from previous research that increasing motivation reduces mind wandering in other settings. So it might be the case that if we can find a way to motivate students to pay attention more, we might be able to reduce their intentional mind wandering behavior. And so I kind of alluded to phone and laptop use in that last section. And you might think that maybe mind wandering isn't increasing over time, but it could just be because students are choosing to disengage in a different way. Everyone has their laptops and phones with them. They're always alluring. You might get a notification. You might want to browse your social media. And so it could be the case that students are increasing the amount that they zone out over time. They're just choosing to do so through their devices as opposed to their internal thoughts. So we studied media multitasking, which is just using your devices for things other than paying attention to the lecture. What we find is that we actually do get a reliable increase over time when we ask people using the thought sampling method to indicate whether they were media multitasking or on task. And then in a follow-up study, we give them more qualitative choices so they can indicate whether they're media multitasking, mind wandering, or thinking elaboratively, which is making links with previous content or with your own life. And what we see is that although the rates are lower, we see that we've replicated the increase in media multitasking over time, and we've replicated the fact that mind wandering remains relatively stable. The key difference here is that we've also included elaborative thought. The rates are relatively low, but this also seems to be stable. And media multitasking adversely affects their performance on quizzes as well across both studies. Okay. So we've talked about various forms of disengagement. It's kind of hard to qualitatively list them all and give students an overwhelming amount of choices during class. So we instead decided in a subsequent study to measure engagement and understanding. So here we can just see, regardless of what they're doing to disengage, how engaged are they? And just look at the more, I guess, positive side of their in-class behavior. So we used our app, we gave them these two sliders to indicate periodically throughout each lecture how engaged they were and how well they were understanding the content. And we expected these things to be highly linked, of course. The more engaged you are, probably the better you're going to understand. And these data were still kind of in the preliminary stages of analysis. But what we see is a small but reliable effect where across 3 semesters with, you know, a dozen some odd different courses, we get this reliable negative relationship between time on task and the extent to which people engage with and understand the content. And so that's significant in all cases and controlling for which student provided the responses and which class they were in. So it does seem like we're losing more students over time. It just might be to media multitasking as opposed to mind wandering. And so for more on these data, I encourage you to come back for the data blitz. Alyssa Smith is going to be giving a talk about some other aspects of this data set. And so to summarize this section, there's a clear difference between video and live lectures with some caveats. Motivation plays a critical role, and it could be the case that, you know, overall disengagement is increasing. It's just people are doing it differently than we've observed in other studies. And so the last thing I want to move on to is how we can kind of use what we've learned so far to potentially apply some interventions. So the main kind of thing to take away is that students are disengaging intentionally for the most part. And it could be due to low motivation, for example, or just kind of low awareness that they're actually changing the extent to which they're paying attention over time. So one approach is to engage in some student side interventions. And so a bit of an aside, but we, in all of our studies recently, have collected just a bunch of qualitative questions about students' attitudes about mind wandering. And so I won't dig into all of these items. These are more kind of exploratory, but I want to focus on this subset. And these questions are basically getting at the extent to which people are actively trying to control how much and when they mind wander, and whether they do so during familiar or new content. The idea that, you know, if they can control their mind wandering, they might do so strategically. And so if we zoom in on these data, a lot of people tend to endorse that they either actively attempt to inhibit their mind wandering, or that they strategically mind wander. Also, people rarely intentionally mind wandering during content that seems new to them. So that suggests that they aren't tuning out if they recognize that this content is something that they still need to learn. And last, people tend to intentionally mind wander more during familiar than new content. But these are all kind of just qualitative observations. So our thought was maybe if there are students who increase or decrease in how much they're paying attention over time, we might be able to give them some feedback about how their attention trends over time. And, you know, given that knowledge and that they intentionally try and control their mind wandering behavior, this might encourage them to kind of sustain their attention at their weak points. So through the app before class, we aggregated about 3 weeks worth of data and showed each person a caricaturized version of their attention curve over time. And then with a caption that told them either their engagement tends to be lowest at the beginning or at the end of class. And then we observed how their attention trajectory behaved for the next 3 weeks. And of course, over that same total of 6 week span, we had a subset of participants who didn't receive any feedback. And so what I'm showing in this plot is the group who didn't receive feedback, so the control group. So we have engagement and understanding. Red is before feedback, purple is after feedback. And in both cases, with no intervention at all, engagement and understanding seem to decline from the first 3 weeks to the second 3 weeks. And these are pilot data, but if we look at the group who did receive feedback, in the engagement case, their rates of engagement stayed relatively constant, where the control group's engagement was declining. And in terms of understanding, they showed an increase in the extent to which they're reporting understanding the content as they're following the feedback. And this is important. We didn't give them any feedback about their understanding. So this could be a byproduct of telling them about their engagement and them in turn taking action to try and remain engaged at their weak points. And so this is just pilot data, but we're following up on this hopefully in a larger sample through remote delivery in the fall. So we'll have more answers for next year's EdCog. Another manipulation we're pursuing is that maybe if motivation is an issue, we can give people a reason to get excited about the content that they're about to see. And so we don't have any data on this yet, but we're hoping to deliver previews through the app that tell people either about exciting content or just some upcoming content in a more mundane way, and see what the impact of that is on how they engage and how they perform on later evaluations. So we're also developing some instructor side tools that can help instructors to understand when students are engaging and potential areas for improvement. So when we are manually inserting probes into the actual lecture slides, we had a pretty strong degree of control over what content was associated with each probe. And so we were able to kind of directly quiz it. One disadvantage of switching to the independent probes on each student's computer, one drawback is that what's actually going on in the lecture becomes a bit of a black box, right? We know what timestamp people are probed at, and we know what slides were presented potentially, depending on the cooperation of the instructor, but it's a little difficult to lock those two things together. So what we did to kind of address this problem was we designed an app for the instructor's computer. And what they do very simply is they install this app, they choose where they want to save the output, they choose one of their screens, whichever one is going to be what the students will see, and then they click start recording, okay? And then at the end of their lecture, they click stop recording. And this is recording no audio, it's just purely like the visual content that's being shown to the participant. Then this makes its way to us, the video file, and we actually have an automated program that will parse that video and basically give us a timeline that shows when the slide changed. So we essentially have this like film reel of what slide was on screen and when. And so this was great for us to be able to determine what content was on screen when people were probed. So it's great for research purposes. But what we realized is we can very easily map on the data from the student side app. And in this way, we can kind of produce these nice visual outputs that show how engagement and understanding fluctuated with respect to the content that was on screen at the time. And so this approach gets more powerful with more data. This was just a very low level pilot, so there's not many data points that we're drawing from here. But the idea is that if we run this in a larger class, we can get like in a given section of a lecture, we can get a sense of how engagement fluctuates over the time course, right? And this is valuable as an instructor because you can see like, when were people not understanding what I was talking about? And, you know, just for pedagogical reasons alone, that's a great tool to have. Students are often slow to report when they're falling behind. This gives you an explicit way of determining when understanding was low. And you can even revisit content that was associated with the valleys in this kind of engagement or understanding curve. The other thing is, if you teach multiple sections, as a lot of introductory psychology instructors do, you get the same engagement curve for the second time you teach that same lecture. And, you know, obviously there's going to be differences in delivery of the time course, but if you notice that there are these commonalities across lectures, that might be a good indication that that's some content that you should target to kind of pivot in your delivery method, change the way that you talk about it. Or alternatively, we could take advantage of some research that shows that interpolating quiz questions tends to regain people's attention, improve retention, improve engagement. And so traditionally, this is just done like throughout the lecture. Quiz questions are randomly plopped in. But imagine that you could, put these in targeted places when we know that, in 2 other sections, we're about to lose people. We can interpolate quiz questions and hopefully bring their focus back just before that period of time when they otherwise might lose engagement. Okay, and then the last thing that we've been working on is whether kind of the instructor behaviors or delivery can actually be used to predict when students will disengage. So with some collaborators, we've been working on a method where you can read in an actual video recording of a lecture, and based purely on pixel movement, it'll automatically determine how much the instructor was moving. And so just to show you an example, here's a video sped up where the instructor is moving around quite a bit. And then what I'll show you here is, the 3 videos on the left were relatively high movement as scored by this automated program. And the ones on the right were relatively low movement. So you can see that the instructor on the right is kind of hanging out around the podium a bit more, whereas on the left, there's a lot of pacing back and forth, maybe a bit more animated with the gesturing. And so the model picks all that up, and we can use it to predict time points during which at the group level, students were less engaged. And what we see is that across a bunch of different classes, and this is like outside of the sample. So the prediction model hasn't seen some of these videos. They're like held out data from the model that we've trained. So in a new lecture that the model hasn't seen before, it can predict the proportion of off-task thought based purely on this automatedly derived movement metric. So maybe not all that surprising, movement is a good thing in your lectures. It can maintain student attention, and that's across a few different classes. More recently, we've tried to extract the audio from these videos and determine what characteristics of speech might predict student attention. And we find that, there's a bunch of kind of really abstracted elements of speech that I don't have time to get into, but correlates of this clear and confident speech predicts engagement. And so that's ongoing work. There's still a lot to be done. But what we found is that movement and speech predict attention. We might be able to give personalized feedback to students so that they can recover focus. And we have this app that gives the potential for instructors to monitor their students' engagement. And so all of these elements together that we can use to collect a lot of data in ongoing lectures might be able to be used to predict attention and produce ideal circumstances for maintaining student attention. So I've told you basically that mind wandering remains relatively stable, but other factors play a role, for instance, the change to video lectures or the presence of other types of off-task thought, including media multitasking. And that we're on track to hopefully develop some more targeted interventions to redirect student attention. And so with that, I want to thank all of my collaborators on this sort of work, new and old, and the sources of funding throughout my postdoc and in developing my new lab. The website's there if you want to learn about this stuff or even join the lab to work on it. So thank you.
Thanks so much, Jeff. That was a great talk. You got me buzzing with lots of ideas for research studies. You've also spurred on a lot of questions. I don't think we're gonna have time to get to all of the questions, but let me just get started on a few of them. So several people were asking just about the nature of mind wandering. So Mark asked, self-caught thought sampling, it kind of seems paradoxical. How can a person monitor what they're thinking as they are thinking? They seem like different processes, and I might just add, how good are human beings at metacognitive judgments about learning and their own thinking?
Right, so I didn't show the data, but what's interesting is that before lectures, we get this questionnaire about how much people think that they mind wander during lectures. And then we can actually map that onto how much they actually do mind wander during lectures. And it's a relatively weak correspondence. So introspection is not great. Like, granted, there's a lot of noise there. With respect to the self versus probe caught question, self-caught's a little bit tricky because we don't really know, like, at what stage of mind wandering do people actually catch themselves. So that's why we use probe caught, which is where we do the catching for them. We kind of stop the lecture and we say, are you on task or are you mind wandering? And then they get a chance to kind of introspect and think about the last 10 or 15 seconds, what they were thinking about. And while it's not a perfect measure, what gives us confidence is that this maps onto so many performance metrics. So across all of our studies, it predicts quiz performance well, which to me indicates that we're picking up on some real phenomenon here.
Okay, so just as people might behave differently if they know that they're being recorded.
Yeah.
If there's a security camera, for example, do you think that students respond differently knowing that they will be probed for mind wandering?
Yeah, so I guess, like, what we do know is that the more we probe people, it's in itself a way to kind of return people to attention. So more probes brings people back on task. So yeah, I mean, we do worry about interrupting too much, but yeah, so the one thing that we kind of do to test for that sort of thing is, in some of the early studies, we had lectures where people weren't probed at all. And then also, as I mentioned when I was talking about the quiz questions, we also quiz content that wasn't directly tied in time to probes. And there's actually no difference in quiz performance between those control days with no probes and the ones where there are probes. So while it's not a direct comparison of engagement, that would be near impossible to get. We do have confidence that it's at least not changing their performance in any, like, strong measurable way, just having these probes present.
Okay. Rebecca asked a question about comparing the video lectures versus live lectures.
Yeah.
What's the difference? And one thing I might add here is that starting the fall, almost all of us are going to be online. And do you think there's a difference between a synchronous and asynchronous lecture? So even if it's the exact same lecture that the person's seeing, maybe from a student perspective, just knowing it's synchronous versus asynchronous, does that change motivation, mind wandering for interacting with the same content?
Yeah, I mean, that's like an open question. And I think, like, some of the studies that we'll be running in the fall are going to help us with some of those questions. I mean, there's two ways it could go for me. The first is that because it's synchronous, you kind of get the one shot to pay attention in the live setting. So maybe your motivation is higher to pay attention. But also with asynchronous content, you can choose to watch it when you're at your sharpest mentally, and you can play and pause if you find yourself tuning out. So it kind of depends, I guess, how motivated your students are, I would guess. But yeah, we'll find out.
William asks, could you give a little bit more detail about this idea of interpolated quiz questions to reduce mind wandering?
Yeah, so this is work from, I guess, mostly Carl Spooner's lab. But we know that, there's a classic finding in memory, the testing effect. The more you kind of practice retrieval, the better you do on later tests. So testing in itself is a learning approach. And so that's just a general effect that we know tests are good and it helps students to learn. There are some drawbacks, but for the most part, it's a good thing to do. And what Carl Spooner's work finds is that when you embed these quiz questions throughout lectures instead of towards the end, you can actually increase the extent to which students are paying attention. So the quiz questions actually have the impact of drawing people back into the content. And so, that's with just kind of randomly placing these quiz questions throughout a lecture. So, what we're thinking is that it might be an even more powerful approach if you know where to place those quiz questions to optimize how much students can stay on task. And so I suspect that that'll do even better in terms of bringing students back to paying attention and improving their long-term retention of the content that we're presenting.
So I could see that tool being especially useful in a recorded lecture situation where nothing's going to change with multiple viewings. So maybe you could find consistent patterns of exactly where there is mind wandering, and that's where you could put in the probe. So that could be really interesting.
Yeah, certainly work a lot better in that case, because I know even if I give the same lecture twice, there's pretty dramatic differences in the time course. So these like common valleys across sections would have to be pretty coarse to map onto each other, I suspect.
Okay, so Thomas asked a question regarding individual differences in mind wandering. For example, do you think that learners with more experience, let's say mature learners, do they engage in more elaborate mind wandering?
That's a great question. I would guess a bit of self-selection comes into play there. Like people who have been in like educating themselves for longer probably are doing that because they're able to pay attention and think deeply about the content, at least in some cases. But yeah, I mean, I would guess that it's a skill just like anything else, right? Like if you're intentionally allocating your mental resources to either the content or to mind wandering, that's a skill. And it's possible that long-term learners are much better at allocating that in appropriate ways, or, even as some of our students indicated, the ones who say that they strategically try to control their mind wandering are often intentionally mind wandering during familiar content. So stuff that they already know, potentially to kind of hoard resources for when new content comes around and they actually need to devote their energy to learning. So yeah, I mean, I think it's a skill probably just like anything else.
Okay, so if I could just add on to that, do you think there might be generational differences? Like say you had a perfect measure of mind wandering, do you think that there'd be different baseline levels of mind wandering? Are there more distractions today? Are people mind wandering more today? I mean, we could even take a step back and look from a historical context or an evolutionary context. How would you speculate on the baseline rates of mind wandering?
Yeah, great question. Really interesting idea. I don't know how much I can speak to it changing over time, but there are these generational differences. So older adults actually mind wander less. And there's some evidence that there's a role for motivation to perform in that. But it could also be just that the younger generation has like a constant onslaught of sources of distraction, right? Like everyone's constantly on their smartphone, or even if you're viewing a lecture on a laptop, it's pretty likely that you have other tabs open and other things going on. So it could be the case that just as a whole, our attention spans are decreasing. But it might be much like my time on task effects in the data I showed, where maybe inattention is increasing generationally, but it could be that the younger generation is just allocating more of their attention to their devices. So yeah, it's an interesting thought.
I think we have time for two more questions. Hongjin asks, can you comment on the possible physiological measures for mind wandering, pupil dilation, EEG, etc.?
Yeah, so I know there are neural markers, but I'm not an expert in what those are. I think in fMRI, they find like default mode network activation, for instance. I do know a little bit about the eye movement metrics, not specifically what the markers are, but there's some excellent work from Caitlin Mills, Nigel Bosch, Sydney DeMello, I believe, where they actually use webcam-based eye monitoring to track student engagement with content, and they can actually use eye movements to detect when people are zoning out. And so that's really promising. They can tell when people are kind of losing track of the thread, and then I think what they've done is actually introduce some intervention that when that's detected, it has like a pop-up or something like that brings them back on track. And then also out of Queens, actually, there's a student, Jeff Harrison. I don't know that this is published yet, but he's working on actually using like eye tracking of a dot that's on screen as an actual metric of mind wandering. So if your task is to follow a dot around the screen as your eyes drift off, they're using that as an actual objective measurement.
If I could just add in a little plug for research we're doing in my lab as well. We're using the live lab at McMaster University. So it's a 100-seat theater where we can measure EEG from up to 40 students at a time who are listening to a lecture. So Noah Foreign and others, we're looking at seeing if we can get interesting neurophysiological measures. So more to report maybe next year at EdCog. Yeah. I'm at the call time there. We have over 26 questions. So I think one thing that we can do is maybe we'll shift these questions over onto the Twitter feed, and we'll tag you, Jeff. And perhaps as you have time throughout the day, you could answer more of these questions